This is a demonstration of Faraday's law using the Colorado PhET apps. If you Google Colorado PhET and Faraday's law, you get this applet. Faraday's law says that if I have a time rate of change of magnetic field, I induce an EMF. I induce a voltage. EMF is another word for voltage. I make a voltage appear if there's a time change of magnetic field. So we're leaving statics, we're leaving electrostatics, we're leaving magnetostatics. In statics, everything was constant in time. Well, one thing could vary in time. The charge could flow. That would mean there's an I, which is a dq dt, but I itself had to be constant. Now we're going to let everything vary. Okay, so if I go to this configuration and move a magnet around a coil of wire, okay, I can increase and decrease the magnetic field in this coil of wire, and I induce an EMF, a voltage here, that makes a current flow. So I see the voltage here, and I see an indication of the current from the light bulb. I can show the field lines. It's kind of distracting, but I guess it's important to do that. So let me sit the magnet here, and I'm in a. Dr. Moffat answered my question. Thanks, Dave. I'll tell you about that later, students. So I'm sitting here, and when nothing is moving, there's no current flow, no voltage. If I make the magnetic field from the south end of the magnet increase, I get a voltage that goes to the right. Okay. If I pull it out the opposite direction, it goes to the left. So south pole field lines coming in from left to right. If I go into the coil, the voltage goes to the right, positive polarity, pull it out, it goes to the left. If I switch the polarities, if I switch north and south here, now I'm making north go there. Now if I go in, it goes to the left, and pulling out goes to the right. So the polarity matters, okay? If I sit with the coil in the middle here and move it back and forth a little bit, even though there's a movement of the coil, of the magnet with respect to the coil, the total number of field lines doesn't change because the field is very uniform there. It's only when I get to the point where the field lines are changing in strength that I get that effect. I can do that any way I increase or decrease the number of field lines, I induce a voltage. That's the subject for the lecture that we start today.